Hello, everyone, and welcome to this talk from Stateless-Serverful to Stateful-Serverless. Apologies for this title. It's easier to read, I think, than say, but this is the point of this presentation. One of the main topics I wanted to cover was about state and about stateless and stateful. So briefly, I'm going to kind of go through a bit of what is stateless and what is stateful, and then we'll go into some code, some examples of some serverless implementations that are stateful. So let's move on. Often when we hear about serverless, we're reminded that there's servers, and it's like, okay, yeah. For us, the people that build applications and run in these environments, we get it. I guess maybe we have to remind maybe our management or our parents or our friends that there are still servers in serverless, but I think we understand that. But with stateless, there is state. And what I mean by this is that there's this concept of when we run an application, those applications are really manipulating state. So you can think of applications as, one way to think of them is that they actually are state management systems. And this one was kind of maybe for you, this is kind of very obvious, but this whole thing of the focus on the concept of state has been predominant in my thinking of late because of Lightbend's move towards what we're calling Akka Serverless. And with Akka Serverless, it's all about being stateful, and it really got me thinking about things like state and those types of things. And really kind of coming to this conclusion is, yeah, right, that it's really, when we build an application, one way of thinking about it is that we're doing state management. What I mean by that is that, say, like a typical shopping cart example, when we're loading up a shopping cart, as each change request comes in to change the shopping cart, like add an item to a shopping cart, remove an item from a shopping cart, change the quantity of an item in the shopping cart, those types of things, each one of those particular operations is manipulating the state of your shopping cart, as well as things like when you check out the cart goes through a fairly profound state change there, where before it's checked out, it's in a state where it's the business logic that we implement allows the changing of the contents of the shopping cart, the items in the shopping cart. Once that critical state change occurs of, say, checking out the cart, then the business logic should be altered to the point where if, say, there was some kind of request that came in to add an item to the shopping cart that's already checked out, that request would be refused. So it's really about this, this kind of state thing all the way through. So what's the difference between stateless and stateful? Well, I want to kind of demonstrate this visually. So what I've got here, and why I'm using this kind of odd thing for doing my presentation, is that I can run a little animation. So in this animation, what I'm showing is that, say, this is say a stateless node, a single instance of our stateless app running, and all these little dots that are kind of appearing out of this node and then moving out and evaporating. These are operations that are, say, being performed against individual things, like individual shopping carts. So imagine this is a little shopping cart app, and there's requests coming in for, I'm making requests to my shopping cart. So one of these dots would be, the state of my shopping cart right now, and as it's being changed to handle, say, an incoming request. One of these other dots could be your shopping cart, and all these other dots are other people's. So the beauty of stateless, though, is that, say, we get a spike in traffic, and we want to, I'm going to just show kind of simulate a spike in traffic here. So we get a spike in traffic. So now this node is getting a bit busy. You know, there's more traffic. Well, the beauty of a stateless app is that you can easily scale it and say start up another instance or a couple instances depending on what the load is, and the requests that are coming in can be distributed across these different nodes on the system. So the same load that saw in the prior picture is happening here, but each individual node in say this cluster of nodes that's handling the shopping carts is less, you know, has a less burden of processing because the load's distributed. A fundamental feature though that makes this work is that it's stateless. So what does that mean? So I've got another little animation that I want to show you in the next slide here. So here I'm going to walk through a stateless processing flow. And the way it works is that, you know, say a request comes in, and I'm going to slow it down here. I'll stop it again here. So a request comes in to what I'm calling the compute state. And this is where I'm also saying this is where your state is hot. So when the request comes in, that triggers a retrieval of the state from, say, cold state, which is the database. You know, so I'm calling the database cold state because your state's frozen typically in the database. You don't change things in a database because the data is sitting on some kind of storage device. And then once that state has been retrieved, we can see the state here represented by this little green ball. Then you can process the incoming request, the command, alter the state, and then go ahead and write the state back to the database and then send the response back. So there's this kind of flow. The state's thrown away. A request comes in, retrieve the state from the database, the state's there, change it, write it back, whatever changes, throw the state away and send back the response over and over. What this means, though, is that any single request for that shopping cart can come in any one of those servers because the servers themselves do not maintain state within those servers. That's why they're stateless. That's why we do stateless, because implementing this is simpler. It's simpler. It's simple for us to develop as developers, but it's also simple to implement for the framework providers and the system providers and those types of things. So this is a stateless processing flow where we're constantly covering the state from cold state, making it hot, and then you're making whatever changes, writing those changes back to the database, and then sending back a response, throw the state away, and repeat, rinse and repeat kind of thing. It's just a cycle over and over. So let's look at a stateful processing flow. Very much looks the same. Let's start it up. So the first request comes in. Now, the state's not initially, it's not in memory. The state's not kept in memory, or it's not kept hot all the time. It's only there when it's needed. So it is, there is a retrieval of the state from the database, from cold state into the compute space into the hot state. So now we got the state, and now we can process that request, the command, and then send our changes back to the database and return a response. But the difference here is that the state remains hot in memory. This is stateful. So then when the next request comes in, we can go straight to the compute step. We can alter the state. We can process the command and alter the state. Of course, we're saving the state change back to the database, and then we send the response back. So this flow goes where now that it's hot in memory, then we're eliminating that step of having to constantly recover the state from a database, which, the difference between measuring things when in the compute space versus measuring things, say, when we're doing some kind of network operation like talking to a database, we're going from billionths of a second or millionths of a second times of timing for compute space to typically milliseconds for databases. Database operations typically, good database operations usually take single-digit milliseconds to complete. It could be longer, but we're saving those milliseconds of time by not having to constantly retrieve the state over and over. And as I mentioned, the state only remains in memory as long as it's actively being used. That's a part of the system. So here the state's gone, say, because it wasn't being used for a while, then we recover from the database, bring it back, and continue processing. But now the state's hot, and we keep it in memory as long as possible. So this is what a stateful system does. But implementing this is more complicated because the challenge is that, say we're in a distributed environment and there are multiple nodes that are computing, there's only one instance of this state anywhere in the cloud, for example. So my shopping cart, you can think of it as like a hot object, which it really is. My state is kind of a hot object in some process somewhere. So if it's, say, it's Java, there's a JVM running somewhere, and my object's in that JVM, and it's only one of, say, many JVMs. So every single request coming in from the outside world, over the internet or over a network, has to be routed to my object. So the routing is the tricky part, which is why we typically don't do stateful systems, because this is a complicated part. But this is something that we've been doing at Lightbend with Akka for a long time, like 6 or 7 years now with Akka Cluster. We've had this capability, being able to have hot state objects basically in memory. So this is kind of some of the features of a stateful system. That first off, it's reducing those IOs. We're taking we're saving some of the time to retrieve the state from the database every single time. And we're also taking a load off of the database, because I don't know about you, but I've been working on backend systems for a long time, typically in Java, even before we call them stateless systems and things like that. But normally when we had performance issues, it was because the database was getting overwhelmed. We could scale our application side, infinitely, as long as we had enough capacity to scale it. But in many cases, it was more difficult to scale the database side. So reducing the contention, reducing the load on the database is a good thing. As an added benefit, the concurrency control, because there's a single writer, as I mentioned, there's only one instance of the object in memory anywhere, then that object, that single instance, is the master of the state changes. So we're also reducing the burden of using the database for concurrency control, which is typically very important with stateless systems. So that there's this single writer concept. The writer, this object instance, a key characteristic of it is that it only handles one request at a time, which, when you think about it, databases have to do the same thing. Databases, because through locking concurrency control, they're serializing all the database activities. In fact, I remember reading once that from the perspective of any single database transaction, all other transactions either happen before or after. You think about that statement, because we always think of databases handling, hundreds or thousands of concurrent operations, but the genius of database implementations is that it's simulating through serialization that key feature of, again, from the perspective of every single transaction, all other transactions happen either before it or after it. With a stateful system, all that's kind of flipped on its head, that it's the state of the single instance of the state object where all the changes occur. So there is this inversion of state, as I was just mentioning, and the concurrency isolation. So enough slides. I wanted to show you an implementation of doing this in not only a stateful system, but doing it with serverless. So I'm going to go into a sample application that I've got here, and this is Akka Serverless. So with Akka Serverless, the way you start building services is that we say it's contract first or API first. So what you do is you start by defining the contract. What does this service look like? I always like to say, what does this service look like on the outside? Well, for something that's going to use the service, what's the API to this service? So the way this is done with Akka Serverless is that you use Google protobufs. So this file here that I'm showing is in using Proto 3 syntax, which is Google protobufs. And then in this file, the syntax is fairly simple. Google protobufs are new to me. I just started using Akka Serverless not too long ago, in the last year or so. And when I first saw it, it's like, okay. When I first heard about it, it's like, oh, what do you mean? I got to define something in another, configuration file or something. I wasn't initially crazy about the idea, but once I started using it, and then I saw, what I'm getting for doing this, it changed my mind. So basically, what you do is you define a message for every type of request that this service expects to receive, as well as any responses. So here's the definition of a add line item. So it's got a card ID, which it has kind of this additional annotation that says that this is the key, this is the entity key for this stateful object, basically the card ID. I've got a customer ID, a product name, and then a quantity in there. And then there's a change item quantity. And the syntax is fairly simple and pretty straightforward. So I've just create these different messages. Also, this one's kind of interesting. The cart, this is kind of represents the full object. So I have a cart message defined here, as it's called in protobuf, where it has a customer ID, a checked out flag, a deleted flag, but then there's this one repeated line item, which is defined up above. So these objects, or the things that we're defining here, can be non-trivial objects. It's not just like a flat object, but it's more. It can be more complicated, like an object that contains a list of other objects. And then more interesting, I think, is where you're defining the service API. You're formally defining it. So there's this RPC add item, which takes in a request with the add line item and returns an empty. Basically, it just returns an empty response acknowledging that everything was processed okay. There's also this Google definition, which allows the service to be accessed via REST. So what we get with this file is that it's defining services that are immediately accessible via gRPC, as well as REST, HTTP REST. So I've got the add item, the change item, that change it takes, and the request change line item quantity and returns an empty. I've got a get defined here that that retrieves the current object. You can see it has a get shopping cart, and then it returns that cart object that I defined up above here. And that's it. So there's also another file that kind of describes what the service looks like on the inside. So it's called the domain definition. I called it an entity because this is for what's called a value entity. So what I'm building here is a key value as a service, a key value as a serverless service. So the data that this service is maintaining is persisted as a simple key value data structure. So I've got a definition of the cart object on the inside, as well as the line item. So the reason for having these two files is that this allows the API, the external access to the service, evolve at a different rate as the internal access to the service. And then these definitions then will generate code. So there's some Java code that's generated as a result of this. This initial file here, this is the actual service file definition implementation here, the shopping cart service implementation for this key value as an entity. So you can see there's this comment, this code was generated by Akka tooling. As long as this file exists, it won't be regenerated. So what it means is that this file goes into some package in source main Java, if you're a Java developer. And once this file is generated, it's intended for us as developers to change it. So it kind of stubs out the file for us. And once it's generated, it won't regenerate unless you delete it, and then it'll recreate it. However, there's other files like this abstract class, this abstract shopping cart class that is generated, and the source is in the target directory. And anytime you say if you were going to make some kind of change to your proto definitions, those changes could be reflected in this abstract shopping cart, which might cause errors because we're extending that abstract base class in our service class implementation. So what happens is these methods are stubbed out, like add item, change item. I didn't write these. These were stubbed out for me by the code generator. But what I did do, though, is I filled in the business logic into these methods. So the code here I'm showing is my own code. So for example, when I do an add item, and this is my style. This isn't a style that you won't even find this in the documentation. It's just something I've kind of experimenting with and settled on at the moment. But what I'm doing is I'm saying reject current state command or else handle current state command. So what I'm doing is the reject method is my validation, and it's an optional. It's a Java optional. So if it comes back empty, then it's going to handle the command. So if there's anything wrong with the command, given the current state, then it will return an error. If everything's okay with the command and the current state, it will return it'll handle the command. Now, the current state you can see is passed in to this method. So what's happening is that the state is stored in some kind of persistence key value store, but you don't have to write any code to retrieve that. You don't have to set up a database. You don't have to, create tables. You don't have to worry about passwords or URLs or any of those things. All that's being handled by the serverless environment. So what's happening is that when an add item request is submitted to the system, an instance of this class is instantiated for the given ID, for the card ID in this case. And depending on the incoming message, the data is retrieved by the system from the underlying key value store. It's serialized into this current state object and it's passed to my method. So all that work is not being done by me. All that work is not being done by you to handle the incoming state being passed to this service. Now the reject method is just it's just doing validation. So things like the customer ID can't be blank, the product ID can't be blank, the quantity can't be less than 1, those types of things. And if anything is wrong, it'll return a optional of an error. Otherwise, it's going to return an empty. The handle, though, is the one where it actually performs the change. It makes the state change. So the way I did it is that you can see that I'm returning, and there's this inherited method called effects, and then there's this method on effects called update state. So I've got a kind of a helper internal class here called shopping cart. So I'm taking the current state and processing the command given that current state, and then I'm changing my internal. It's kind of a plain old Java object, this shopping cart class that I implemented. Again, this is my own coding style, so it's kind of deserializing, or it's kind of taking the data out of this current state object and putting it into a plain old Java object. Then I have a method that handles the add item command, and then I change it back into a state object. And then the update state method is where this state change will be persisted. So again, this is the only operation that I have to do, or you have to do in our code to save the change. and then you do a then reply. So you can see that, I've got a method for add light item, change light item, and you can see the pattern is like, it's just cookie cutter the way this is implemented. And then, the logic is in this handle method in my Pojo. So just coming in, and it's pretty simple, but I'm adding an item to the list of items, that type of thing. Pretty straightforward stuff. So that's it. The code is actually really simple, and it allows you really to focus almost all of your attention on business logic, not on all the other stuff. Like to set up a service, you basically create your proto definitions, you write this code, you deploy it to Akka Serverless, and you're running. And you've got a database set up, and you're persisting data, and you're going. So let me just wrap up here. So the service that I've implemented, and I'll give you the links to the code if you're interested in taking a closer look. I just showed you one component, which was a shopping cart as a key value as a service, this little box here. But there's a whole series. There's actually 2 services that I implement, because in Akka Serverless, the hierarchy is kind of, you create a project in Akka Serverless. Project contains services, and services contain components like a key value as a service, or event sourcing as a service, or CQRS queryable views as a service. I don't have the time really to get into this, but this is the CQRS. So you can do event sourcing, you can do CQRS, you can do key value with CQRS. Also, there's code that really easily uses topics. Today, it's Google PubSub. Soon, of course, it's going to be Kafka. That feature is coming out very soon. So the sample project, I'm kind of trying to demonstrate not only kind of the core services like the event sourcing service and the key value service, but also views, taking that, doing CQRS with these services, and also doing some stuff with publishing and subscribing to topics. Series of links. It's quite easy. If you just go to GitHub and you look for my users McKee H3, and you just look for shopping cart Java, Akka Serverless, that's the main service that has the shopping cart code in it. And I've got a kind of real simple service called shopping cart pub Java Akka Serverless. That's the service that publishes to a topic, and the shopping cart, this first one, is the subscriber to that. You can test it both ways, but this is the source code. So with that, thank you very much. I just got a little bit of time left here. I'll see if there's any questions. Go to the Q&A section. So there's just my buddy Oliver, who works at Lightbend. What does the developer normally have to do with DBs or message buses, function steps that don't have to think about with Stateful-Serverless? And I think I've kind of covered that with the whole thing of it. We call it databaseless as well, Akka Serverless, because there of course there is a database there, because we have queryable views and the queryable views are done in pretty much the same way, where there's really no database to set up, but you do define how you can query your data using a SQL syntax type of definition. And but I don't know. I mean, often, like I often set up demos, and I have to kind of start from scratch, where I have to set up databases and Kubernetes and this and that, and that's a lot of work sometimes to get it all working and make sure everything's good. Even configuring secrets and like for username and password and so on. All that stuff's gone in this kind of environment. So if there's no other questions, thank you for your time. You feel free. I'll be around for a little bit to. Okay, just got another one. How does Akka Serverless implementation compare to services implemented using the logon framework? Good question. And I was told, because we're going in a break, we can go over a little bit. So the question is about how does Akka Serverless compare to logon? I think it's really interesting because if you look at logon, I think a lot of the inspiration for Akka Serverless and its components like event sourcing and views and so on is the kind of the inspiration for how Akka Serverless works. So with logon is a kind of a build microservices with guide rails, and the guide rails were a very kind of nicely prescribed way of implementing microservices. So there's like simple components that you have to implement as a developer. One of them being that it's kind of event sourcing out of the box. So in logon we had event sourcing out of the box. In Akka Serverless there's event sourcing out of the box, and it's even easier in Akka Serverless. So if you're used to building logon microservices, I think you'll find some real similarities in Akka Serverless. And I hope that it will be a delightful developer experience because you'll not have all the kind of setup stuff that we normally have to do in, say, traditional microservice types environments. And then another question, how does serverless handle load balancing? Another really good question. So of course, like with all serverless, like the leader Amazon with Lambdas and so on, the big thing about serverless is it scales, it auto scales. So it's the same thing here, that the system will scale up as the load goes up and it'll scale down as the load goes down. And under the covers, it's Akka. So Akka has been scalable. Akka clusters have been scalable for long, since Akka clusters came out, like 5, 6, maybe even 7 years ago. And we're taking all that experience and expertise and we're applying it to a serverless environment. So another feature is that there's no cold starts with Akka Serverless. Is Scala equally supported like Java for Akka? Yes, the Scala SDK just came out. The engineers at Lightbend were really wanting to get that implemented because they're all high-powered Scala developers. So there's a great Scala SDK. There's similarities between the two. So again, thank you very much. We went over a few minutes. It is a break, so feel free to take a break. But I'll stand by if somebody has another question. I don't know about, somebody asked about pricing. Is there a price comparison between using traditional stateless approach? I don't know we don't have the pricing yet. We're just getting close to announcing general availability and pricing, but I haven't been privy to any pricing information myself yet. How do you implement read-side projections? Yeah, that's a good question. So read-side projections are kind of a logon term, and those are, look at the views in Akka Serverless. So views are very, very much like read-side projections. And I think, because I've done both, that the read-side projections and the views in Akka Serverless are much simpler. In Akka Serverless, can we specify what DB? No, you can't. The database is out of our control. So right now, you can't specify which database. In fact, you don't even know what database is being used. There's nothing to tell us as developers what the actual backend database is. And so it's out. Thank you for the great questions. I really appreciate it. Stay tuned also for anybody still around. We've been producing a number of videos, trying to keep them short about Akka Serverless, and more coming all the time. So we're really focused on trying to produce a lot of content to help developers there. Should we plan to export data out of data warehouses for analysis? Yes, that's a good question. Should we plan to export data out to data warehouses for analytics? Can that be done? Absolutely. In fact, that's why it was so critical for the Akka Serverless key value and event sourcing to be able to communicate with message buses like Google Pub Sub and of course to Kafka. So you can implement your services in Akka Serverless, and then the data will be pushed to, say, to a topic that would be consumed by say some kind of a data warehouse or something like that. Does Akka support supervision? Does Akka support supervising trees like Erlang, for example? Akka does this, but that's the Akka platform. So when you're implementing Akka actors, it does have that supervision hierarchy between actors, similar to Erlang. In Akka Serverless, we're not dealing with actors. It's more we're dealing with these components, like event sourcing as a service, like key value as a service, like a topic consumer, a topic producer, a view, building views, those types of things. So there, it's not really quite like an actor Erlang type of environment. All right. Great questions. Appreciate it. I think we're probably out of questions. Maybe. I'll wait a bit, but I think we're out. The other thing I'll mention is that with most serverless offerings, I think a big deal is that it's easy to try. And as developers, of course, we're always having to learn new things. And but often you can try out something with serverless, and this is certainly the case with Akka Serverless, easily and for free. So there's a free trial with Akka Serverless where you can give things a try. Even if you were, say, that the free trial expired, it's easy to create a service, run it for a little bit, and then delete it. And then, if you don't have any services running, you're not going to get charged anything. Okay, here's another question. Is Kafka usable in conjunction with Akka event sourcing? There are discussions on Stack Overflow. Absolutely, where the event sourcing implementation in Akka Serverless, as I mentioned just a moment ago, can easily be plugged into some kind of a message bus. I don't know when the availability of Kafka will be there, but it's going to be there very soon. I think real soon. We've already got Google Pub Sub. The programming part of it is really quite nice, but pushing data into a topic that goes externally to, outside of Akka Serverless is really easy to do. That also applies to the Akka platform, which, the non-serverless side, where say you implement event sourcing on the Akka platform, which you can easily do, you can easily integrate that with, publishing to a topic. And it gives you guaranteed at least once message delivery, which is, I think, pretty critical. Oh, by the way, there's also a discussion. If you go to Akka Serverless, there's a discussions forum. It's The link to it is right in the Akka Serverless console. Up in the top right, there's a drop-down menu with links to documentation, but there's also a link to discussions where you can open a dialogue with us, ask questions, bring things up. We really would love to see people come in and join that. So if you have more questions after this, you can certainly go there. In a regular actor system, I can add logic, interact with actors on a low level. For example, I can do something when an actor is going to passivate. Can I do these in serverless? Not quite. You're dead on. If you know Akka actors, then you know a lot of the mechanics that's happening in Akka Serverless. So obviously you know about passivation. And what passivation is, that when I was kind of demoing the stateless flow, I said that the state remains in memory as long as it's active. When it's not active, the state is removed from memory, and that's called passivation. And the idea is that it goes out of memory. In Akka actors, you can implement a method that can override a method that will be triggered when passivation occurs. In Akka Serverless, it doesn't have that feature. But the other thing I wanted to say, I'm glad you asked this question. It's early days, and input from you guys, from the developers, will be looked at very, very closely and taken very, very seriously. So features that you think you would like to see, I really, really encourage anyone that uses Akka Serverless to be vocal, to tell us what you like, what you don't like, what you would like to see. I've been doing that. That's my job. I'm developer advocate. So I've been harassing, I love to think of it that way, harassing our engineering team and our product team with questions, and I don't like this documentation, or I want to see a feature, or why can't I do this? So please, if you start using it, be vocal. Don't hold back. Does Akka SLS support Canary development? Not formally, but no, it doesn't. Not yet. I could be, somebody might say I'm wrong, but as far as I know, no, we can't do Canary deployment yet. Nice feature request, though. Akka Serverless was released recently. What is stability at the moment? Are there any issues? Is it used in production by customers? As we announced GA, this is when we're flipping the switch from saying GA, general availability, from flipping the switch to, all right, we're serious. We have full-time support and full 24/7 monitoring and operations, and we want people to start using this in production. So it's ready for production now. Like I say, I think we're announcing GA here at the Reactive Summit. I can't tell you how serious we are about Akka Serverless as well. I've been in Lightbend for about 5.5 years, and it's like our moonshot project at the moment. We're dead serious about this, and being production ready is serious. But we're very confident because the underlying technology is extremely mature. Being Akka, we've been doing these things for a long time. It's kind of battle hardened. Oh, you guys are great. There's still a number out there. I don't want to hold you up for next sessions. I think the break was only, what, 10 minutes? Got 1 minute until the next session. No, it starts now. All right, I think I'll let you get on to other sessions. Again, I really appreciate those that stayed on and asked so many great questions. Really, really appreciate it. Thank you very much. Enjoy the rest of the conference.